Okay, so I wanted to take some time just to go through some plotting of points with you. The polar graphs, the polar points that we plotted on Monday, they were pretty easy, but once you start putting them into an equation form, it gets a little bit more challenging. So if you haven't already, you need to print the day 68 practice, notes, practice, and exploration page. So hit pause real quick and go and print that and come back. All right, so here we go. The idea here is that we want to graph an equation on a polar grid. The first thing that we're going to want to do is we're going to calculate the values of R. R is going to be the dependent value, and theta is going to be our given value. And we're going to start at 0 degrees, and we're going to rotate around until the graph completes itself. Now that doesn't mean rotate till 360. Sometimes it's rotate more than that, but usually it's 360 degrees. If we're doing it in degrees, it's from 0 degrees to 360 degrees. And if you were doing it in radians, you'd be doing it from 0 pi to 2 pi. I'm particularly, because we're in distance learning, I think it's probably better for us to stick to degrees than to do radians. But I do know that computer programmers use radians for this, for when they try to make curves. Making curves is a thing that needs to happen in lots of design issues. So we're going to fill in the chart with the information, and then we're going to connect the dots. We'll talk about the symmetry and all that stuff in a few minutes. So let's make this a little bit bigger. Okay. So the theta values that we know 0 degrees, and then we're going to do 30 degrees, and then we're going to do 60 degrees, and then 90 degrees, and 120. We're going to count by 30s. 135, nope, not 35, that would be counting by 15s. Let's see if I can erase this. 150, 180, and hopefully by the time we get to 180, you can see the pattern that's happening, and you'll be able to continue on your own and do 210 and 240 on your own and finish up the shape. So I'm going to get you halfway there. So if theta is 0, what would R be? We're going to plug it into our equation, which is in the R equals format. So 1 minus 2 cosine theta. So R equals 1 minus 2 cosine of 0 degrees. So I have to calculate the cosine of 0 degrees. That's 1 minus 2 times 1. So 1 minus 2 is negative 1. So the R at 0 degrees is negative 1. That means I need to plot that point. Don't move on and do the next part of the chart until after you've plotted that point on the polar grid. So our input is 0 degrees, so we're going to face this direction, standing at the pole, and we're going to move negative 1 degrees in that, negative 1 radians in that direction. Now because it's a negative, I have to go backwards. So this is the location of 0 degrees at negative 1 radius. We learned how to plot points on Monday. Hopefully that's making sense to you. You face 0 degrees and you step backwards 1. All right, next one, I'm going to go with the 30 degrees. Change that, change that, change that. 30 degrees. Cosine of 30 degrees is root 3 over 2. Negative 2 times that is going to be negative root 3. 1 minus root 3. I'm going to grab my calculator and ask my calculator, what is 1 minus the square root of 3? Enter. And it tells me, let me move that down a little bit for you. It tells me negative 0.73. Oh, I'm in degrees. Just checking. See, I am in degrees. So negative 0.73. Negative 0.73. negative 0.73. So I'm going to face 30 degrees. That's this one facing 30 degrees. And I'm going to stand at the pole and I'm going to walk backwards because it's a negative. I'm going to walk backwards negative 0.73. Ooh, I am not even going to make it to the first ring. So I'm going to go negative 0.73. So there's the next point. Continuing with this process. And it is just a process. So erase, erase, erase. And 60 degrees. Oh, you know what I forgot to do? I forgot to connect those 2 points. Connect. Play connect the dots. All right, cosine of 60 degrees is 1/2. 1 minus 1 is 0. So at 60 degrees, I am going to have a radius of 0, which means I'm going to stand at the pole, I'm going to face 60 degrees, and I'm going to walk nothing. Dot. Doot. Connect the dot. Walking nothing. A radius of 0 is that you are on that inner pole and you don't get to walk anywhere. So I have this little U-shaped piece that's happening down here. All right, continuing. Well, let's see what happens. We are going to change that to a 90. 90. Cosine of 90 is 0. 1 minus 0 is 1. So at 90 degrees, I'm going to go face 90 degrees. I'm going to walk from my pole towards 90 degrees, 1 radius. There we are. And I'm going to connect the dot. Boop. Looks like a J. Wonder what this is going to be. Moving on. Talking about wondering what it's going to be. I have in my head what it's going to be, but that's because I know some rules, and you're going to learn some of those rules today after we plot a couple of them. All right, next one is 120. 120 degrees. 120. The cosine of 120 is negative 1/2. 2 times negative 1/2 is positive 1. 1 plus 1 is 2. 2. 120. I'm going to face 120. And I'm going to go out to the second ring. Oh, that's interesting. I feel very much like I'm just making a curlicue. Moving on in my process. And do it again. Hey, it's helpful if you remember your unit circle, 150. The cosine of 150 is the same as it was for 30. Except it's the opposite. So I'm going to be doing 1 plus root 3. That's my friendly calculator. What is 1 plus root 3? And look at what I asked the calculator the last time I had to use it. All right, we into 273. Reduce 273. 2 rings, 2.73 rings. I'm going to face 150 degrees, which is here. 150. If you haven't figured it out yet, this entire polar grid is marked off in 15 degrees. Each one of them 15, so there's 45 if you wanted it. But I'm only writing out things in 30s just because I don't feel like, I could do all of those degree measurements, but I think I'm going to be able to get the picture just by counting in 30s. All right, I need to go face 150. Where was I? 150. And I'm going to walk from my pole 2.73 rings out. Not 3 rings, 2.73 rings. And I'm going to connect my dot. I can see that it's supposed to be a curve, so I'm going to make it a slight curve. Spiral. Spirally. Spirally. Maybe it's a spiral. Oh, okay. Moving on to 180 degrees. 180. What do you think 180 is going to be? What do you think? I think I'm going to put a fancy little 180 right there, and another little 180 right there, and I'm going to Bob Ross this. Oh, the cosine of 180. Oh, I shouldn't be putting 180 there. Cosine of 180 is, let's make that prettier. -1. 1 plus 2 is 3. 3, a beautiful 3. I'm going to face 180 degrees, and I'm going to go 1, 2, 3. All right, spiral, spiral, spiral. What do you think is going to happen for the rest of it? You're going to plot in a 210, and you're going to plot a 240, and you're going to plug it in, you're going to plot, 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 and you're going to get to see the rest of this picture on your own. Good luck. One of the things you're going to get to talk about is you're going to get to talk about symmetry. Let's look at this piece right over here. Yeah, I don't want to do that. Boop. Boop. Come here, you. Symmetry. You're going to get to talk about symmetry. If there was line symmetry, if there's like it folds like a butterfly, you get to talk about point symmetry, where if it looks like it's a spiral, or not spiral, if it looks like a flower, it'll have point symmetry, where you can spin it on itself. The maximum value of R, that's going to be, looking at this list, which one was the highest one? Right now, the highest one is 3. Ooh, so sorry. Darn. Let's see if I can fix that. So is 3 going to be the maximum of the radii that are in this problem? And then 0 of R. Which one of these ends up being a 0 in all of the list? And you're going to finish the list yourself. Right now, I can say that 60 degrees is a 0 of R because it results in a 0 for where they are. So 60 degrees is my input value that has an R of 0. So it is called one of the zeros of R. All right, so I'm looking forward to seeing what you guys come up with for the other part of that graph. Like I say, take it easy. Point by point, plot by plot, connect the dots, and the picture will come out. You may not have to go to 360, or you might have to go all the way to 360. I feel like we've gotten like halfway around. Maybe it's a 361. Anyway, you'll get the rest of your picture as you go through the process. All right, let's move on to the next example. This one is 2 cosine 3 theta. Same thing, we are going to plot points and play connect the dots. So I'll move it up a little bit more because you guys have the notes on your page. Make this one a little bit bigger. Okay. And you know what? If you guys want to come back to this one, I'll do a different video for example number 2. That first one, that was called a Limacon. This one's a rose. I'll save this rose example for another video. Y'all have a great day. Hey, make sure you move on to the practice that's for the Limacons, and then you answer the quiz, the Google form quiz, after you've practiced on your graphing calculator. So really the next thing you're going to do is you're going to practice little plotting points, and then you're going to watch the video on how to set up the modes on your calculator for polar, and then you're going to explore your polar equations on for the Limacons. And then you're going to take the Google form quiz. If you're confused, just open up the Learn from Home learning plan for the day, and you can follow that and get everything turned in. All right, talk to you later. Bye.